So in this eighth video in the tutorial series, I would like to give you an idea of what these curves mean. Think of it like this. These curves represent the signal as it leaves the filter system. Now, you're using this signal to, well, either to move one of the degrees of freedom on a 60 UF rig, or to directly use it to drive an actuator on another, like on one of these racing rigs. So you should have an awareness that if the value of that signal represents the position of that degree of freedom, then the gradient of that signal, like the amount of change over time of that signal, represents the speed at which that degree of freedom changes. And if the gradient represents like the rate of change of that signal, then the curvature, yes, that is an oversimplification, but let's just use the term curvature. Actually, it's the second derivative. But the curvature, for example, of that yellow graph right here, in this very point, the curvature of that graph represents the acceleration. And in this case, in the case of the red graph here, the change in curvature in this case is the jerk of that degree of freedom. So the value of that signal is the position, the gradient is the velocity, the curvature represents the acceleration of that degree of freedom, and in case of the red graph, the change in curvature that you're experiencing right here, the change in curvature over time, that is the jerk that you're using. So if you want to use these graphs, these signals to drive your rig, you should be aware of what these values mean. Because only then will you be able to make the decision yourself of whether or not you need a first, a second, or a third order low pass filter for the job that you're doing.